So in this video, we'll be going over the two problems that deal with a bullet moving towards a target and then hitting the target. So for this first problem, we have a 5-gram bullet. It's traveling at 300 meters per second, and it goes right through the target. We're told that the target has a mass of 500 grams, and that the target was initially moving at 5 meters per second towards the bullet. The bullet emerges with a speed of 150 seconds. Remember, it passes through. How fast and in what direction will the target move? So what are we looking for? We're looking for the velocity of the target after the collision. So again, with every problem, the first thing you want to do is define a coordinate system. Since we have vectors here, momentum is a vector, velocity is a vector. I'm going to choose to the right to be the positive x direction. And now, since we've defined our coordinate system, we can start labeling our knowns and unknowns. So to start, we're told that the mass of the bullet, I'm going to call it m sub b, is equal to 5 grams. We're told that the velocity of the bullet, VB, its initial velocity, is equal to 300 meters per second. That's positive because that's moving to the right. For the target, we're told that the mass of the target, MT, is equal to 500 grams. And then we're told that the initial velocity of the target is moving towards the bullet. So it's going to be moving towards the left. So VT sub naught is equal to negative 5 meters per second because it's moving towards the bullet. We're told that after the collision, the bullet passes through the target. So it's going to emerge to the right of the target. And that is going to be moving towards the right. And so VBF is equal to 150 meters per second, and that's positive because it's moving to the right. And then finally, we're asked to figure out what is the final velocity of the target, FTF, and we want to know the direction. So let's think about this. We have momentum, we have positive momentum at the start towards the right because of the bullet. We have some negative momentum towards the left from the target, and then the bullet is continuing to the right with some momentum. And so after the collision, we still expect there to be some momentum to the left. So the most likely probability is that the velocity of the target is pointed towards the left and is negative. So again, just writing down here to finish up, we are looking for the final velocity of the target. The best guess is negative. If you get it wrong, that's okay. Again, it's just a guess to think about what direction do we expect it to turn out to be. So let's go ahead and get started. Let's use our conservation of momentum equation for two objects, where the initial momentum, P sub I, is equal to the final momentum, P sub F. So we can apply that to our situation where we have the mass of the bullet times the initial velocity of the bullet plus the mass of the target times the initial velocity of the target is equal to the mass of the bullet times the final velocity of the bullet plus the mass of the target times the final velocity of the target. None of these quantities are zero because we have movement in the initial start of the problem, and then we're expecting movement in the final. So since we can't cancel anything out, let's go ahead and rearrange this. We're looking for the final velocity of the target. So we want to solve for Vt sub f. So separating out and getting that on its own, Vt sub f is equal to 1 over the mass of the target times the mass of the bullet times the initial velocity of the bullet plus the mass of the target times the initial velocity of the target minus the mass of the bullet times the initial or the final velocity, of the bullet. And we can just rearrange that a little neater. So I'm going to multiply through the mass of the target. I'm going to be left with the mass of the bullet over the mass of the target times the initial velocity of the bullet minus the final velocity of the bullet plus the initial velocity of the target. So I'm going to box this because we're actually going to use this same exact expression in the next problem. So now we can just substitute all of our known quantities in. We don't need to convert the masses into kilograms because they're both in terms of grams. So since they're both in terms of grams, those units will cancel out and we're going to be left with meters per second, which is what we're expecting for a velocity. So the mass of the bullet is 5 grams divided by the mass of the target, which is 500 grams. And you see we have grams over grams, and so that's how they're going to cancel. The initial velocity of the bullet's 300 meters per second minus the final velocity of the bullet, which is 150 meters per second, plus the initial velocity of the target. That was moving to the left. Sorry about that. That was moving to the left. So that is -5 meters per second. Plugging all that into your calculator, you find that the final velocity of the target is equal to -3.5 meters per second. So it is moving to the left since we have some momentum to the right from the bullet and the final. So we expect that target to be moving to the left. So everything seems to be good to go. So now we're going to look at a very similar problem, except that there's a difference with what's happening with the bullet after the collision. So again, we have a 5 gram bullet, 500 gram target. The bullet's initially moving at 300 meters per second to the right, which it was before. And now the only difference is that the target is stationary at the start and the bullet recoils with a speed of 150 meters per second. So instead of continuing right through the target to the right, it now bounces off to the left. So you may have seen in movies or just kind of intuition, if the bullet bounces off a target, you may have seen where if a target's free to rotate, it just spins around. So just kind of going off of that scenario, we expect that the target's probably moving to the right in this situation instead of moving to the left. So why don't we label everything? We have the mass of the bullet, it's equal to 5 grams, mass of the target is equal to 500 grams. The target's stationary at the start, so Vt naught is equal to 0 meters per second. We know that the initial velocity of the bullet is equal to 300 meters per second, and then the final velocity of the bullet is moving towards the left. So the final velocity of the bullet is equal to -150 meters per second. So that's going to be the difference. And then for the target, as we just said, we kind of expect that the final velocity of the target is going to be a positive value. It's going to be to the right so that we conserve momentum. So again, the coordinate system is going to be positive. X direction is going to be to the right, just like up above. And so since we solved the momentum equation up above in terms of just the variables, we can reuse that same momentum equation. Nothing has changed. We'll just need to alter the initial velocity of the target to make that 0 meters per second. But since we solved it generally up top, including all of the terms where we didn't have to drop anything out because we couldn't drop anything out of the momentum equation, we'll be able to use that and apply that here. So again, we're looking for the final velocity of the target. We're expecting that to be positive in units of meters per second. So again, starting from this momentum equation, and if you didn't pick up that we could still use that same equation up top that I had boxed, it's okay to just start from here again, and you'll never go wrong with that. But I'm going to use this equation right here that we solved for up top, because that applies here. And then at this point, we just need to substitute in. So we have the final velocity of the target is equal to, we have 5 grams for the bullet, 500 grams for the target. The initial velocity of the bullet's 300 meters per second minus the bullet and after the collision is traveling to the left with a speed of 150 meters per second. So it's going to be a negative 150 meters per second for the final velocity of the bullet. And then the initial velocity of the target, remember, it's stationary in this time. So this is just going to be 0 meters per second. So again, since we kept it general up above, we can just reapply this equation since it's the same physical situation and just resubstitute in the numbers that are applicable. So this is a vector. So again, you just need to substitute in and solve. Doing that, we find that the final velocity of the target is equal to 4.5 meters per second. So that's a positive value, so we know that the target is moving towards the right with a speed of 4.5 meters per second. So that's what we expected based off of these physical grounds. Units are all good, so everything seems reasonable.